Hi dear students, welcome to the next we are at the end of the final session of this chapter. Today we are going to see the numericals, the problems which are already came for NEET and JEE entrance examinations, as well as there is a high chance to ask some of the questions which are interested to us, and at the same time which will be helpful for us to do. So we are moving to the problem solving sessions from units and dimension. This session is quite important. Definitely you have to remember or you have to recollect all the things what you have learned before, because there and there we have learned about the different concepts like different dimension formula, screw gauge, error analysis, so many topics. So all things should be in your mind, and based on that we are going to do the problems. We'll do a few questions from various topics which are touching in and across the chapter. Okay, so I have my phone's hand with me, so I have the question papers with me, also available as a soft copy. You also have the copy, I hope so. You will also get it, this copy, and also meanwhile I will in a short I will display the questions on top of this board, so you can just pause the video in case you are not with the question papers. Okay, so expectations, you should have the question paper. In case if not have, questions will display. Pause the video and write down the questions below. I will solve this one. Okay, so let's move to question number 1. First question number 1. Density of the material in CGS system of unit is 4 gram per centimeter cube. In a system of units in which length is 10 centimeter, unit of mass is 100 gram, value of density of the materials will be. We will list the things which is already given in the question. For example, density rho is given 4 gram per centimeter square. And the unit of mass they have given is how much? 100. And unit of length they have given how much? 10. Okay, so this is in CGS system. There are two systems will be there, not only two systems, many systems are there, but commonly two systems. CGS means length in centimeter, G means gram, mass in gram, S means time in seconds. Other one is SI system in international. Our normal mass in kilogram, length in meters, time is in second. But here question is asking in terms of CGS system, centimeter gram second system. Okay, so in this question density is given and unit of mass and unit of length is will be also given. For example, here unit, they are saying the unit of mass is this one. Normally if you are converting from one unit to another unit, what normally will do, for example in a CGS system 1 gram is how much kilogram? 1 gram equal to 1 divided by 1000 kilogram. Correct? 1 kilogram equal to 1000 gram. 1 kilogram equal to 1000 gram, right? You know, so 1 kilogram is equal to 1000 gram. This you know, 1 kilogram is equal to 1000 grams, you know. So 1 gram is equal to what? 1 divided by 1000 kilogram. This is what we have written. So normally will divide the unit in case of a CGS system if you are converting from a CGS system into an SI system. So here I put thousands. Why? Because I need to get it as a kilogram. But here we don't want to get it as a kilogram. Question is asking, I am converting to this unit. Here 1000 is divided in order to convert into a kilogram unit. Got it? But I don't want to convert into kilogram. I need to convert. Question is saying I need to convert to some other unit. And the denominator value in that case, what should come for mass? This one. For length is given like this. So we'll write density equal to mass divided by volume. Density equal to mass divided by volume. The density is given, density of the material is given, it is 4 gram per centimeter cube. We'll convert 4 into gram means mass. So 1 gram is taken because it is not mentioned as it is as 1 gram. For 1 gram mass by default, if it is not given like okay 5 kilogram of mass, it is not given something like that. So mass is 1 kilogram, length is in 1. Next, gram I am converting to the required unit. What is the required unit? Unit of mass. Here unit of mass in kilogram. In kilogram is how much will come? 1000 will come on the denominator. Here unit of mass is coming as 100. So 1 by 100. So mass is over, gram is over. Next one, centimeter cube. Centimeter cube means volume. Volume means 1 centimeter. Converting to the required unit. What is the required unit? 10. So this is in length. So how will get volume? Length in the cube. Okay. So what will happen? We'll got 4 into thousands divided by 100. 2 zeros get cancelled. Answer is 40 unit. Answer is 40 unit for this question. It's matching, right, with our option number B. It is 40 unit. Okay. Let's move to the next question. Hope you understood. Let's move to the next question. Question number 2, second question. Question number 2. Time period of a body under SHM, simple harmonic motion. SHM in the abbreviation on simple harmonic motion is represented by T is equal to P power A D power B S raised to C. P is a pressure, D is a density, and S is a surface tension. This kind of problem we already done. This is a time period, right? So what we will do, we need to find out what is the value of A, B and C. We'll substitute, will be here. So time period, so we'll write the time period formula. What's the time period formula? M power 0, L power 0, T. Only T will be available, which is equal to P means pressure. Pressure means what? Force divided by area. So first we will find all the required things. Pressure equal to dimension formula of pressure. We have to put it like this, the bracket. Okay, this is required, especially you are writing for your board examinations and all, but for entrance we can straightforward write. It is called force divided by area. What is force? ml, mass into acceleration. ml t power minus 2. lt power minus 2 is acceleration divided by area, L square. L get cancelled. ml power minus 1, t power minus 2. So we got the dimension formula for pressure. Dimension formula for density. Density is what? Density is equal to what? Mass per volume. So what is mass? M. Volume means what? L cube. So dimension formula is ml power minus 3, length in the cube volume. So we got. Next one is called a surface tension. What is the dimension formula of surface tension? Surface tension means force per length. Force mlt raised to minus 2, length L, get cancelled. So what is the formula? mt power minus 2. So we got all the formula. Will substituted will be here, and this equations number 1 I am rewritten as m power 0, L power 0, t power 1. Time period. Time period means only time is available. Mass and length is 0. Right hand side, pressure formula we know is equal to m power. It is with the A. So we have to multiply A everywhere. So m power A, L power minus A, sorry, L power minus A, correct, T power minus 2A multiplied with density m power B, L power minus 3B multiplied with surface tension mt raised to minus 2. So m power C, T power minus 2C. Okay. Pause the video and write it up to this one. We are equated LHS with RHS with the given dimension formula. Now we'll move forward. Okay. What we are going to do will be here. We are going to solve this one. So we are taking the coefficient of A. Coefficient of A is LHS, it is 0. RHS is how much? What is the value of RHS dimension formula? A will be here, B will be here, C will be there. So it is A plus B plus C. Equations number 1 will give it as, or 1 is already given. Equation number 2 will give. L in the coefficients, L equal to 0, minus A, minus 3B. Anything there? Nothing. So equation number 3. Third one, coefficient of T. Left side 1, right side minus 2A. And here there is no T. Here it is minus 2C. Minus 2C. Equation number 4. We have to solve all this equation. That is what our aim. Okay. So what we can do here. We have couple of formula. What I'm going to do means I'm going to add 2 with 3. The 2 and 3 equations, if I add, what will things will get? A will get cancels. I will get a formula. LHS is 0. A and 0. Minus 3B plus B is equal to minus 2B plus C. Equation number 5. Now, minus 2B plus C. Okay. So we have all this set of equations. We need to solve these equations and we need to find the value of this one. Okay. This is what is our aim. So what we can do? Minus 2B plus C we have equation number 5 and equation number 1. So if you have getting an equations in terms of A and C, then that will be easy, right? Okay. So we'll do one thing. Equation number 2. Equation number 4 I keep it as such it is. I need to get an equations to have with A and C. To have it with A and C. So let me look into equation number 2. Equation number 2 I multiplied with the minus 3B. So equation number 2 multiplied with the minus 3. So what will happen? 0 equal to minus 3A minus 3B minus 3C. This is equation number 6. Okay. Now I have two equations. Equation number 6 minus equation number 3 I am doing. Equation number 6 minus, we are basically solving the 3 equation. Equation number 6 minus equation number 3. So minus 3, LHS it is 0 equal to minus 3A minus minus A. So it is minus 2A. Minus 3B minus minus 3B. So it is 0B. And minus 3C 0. So minus 3C equal to equation number 7. Okay. So let's move further forward. You have to solve. You don't want to solve like this one also. This is my method. You can follow any method, but finally we need to get the value of A and C. Now we have these two equations, 5 and C. And sorry, not 5 and C. We have 4 and C. Okay, A with the C equations. Both sides equations are same. I am doing equation number 4 minus equation number 7. Equation number 4 minus equation number 7. Minus 2A minus minus 2A. So this will get cancelled. Minus 2C minus minus 3C. So what will come? Just C on the right side. Right side. Left side what will come? 4 minus 7. So 1 minus 0. So which means 1. 1 equal to C. So now I got C equal to 1. I can substitute in equation number 4. So equation number 4 become C equal to 1. I know. So I am substituting 1 equal to minus 2A minus 2 into 1. So minus 2 into 1 means minus 2 will come to right hand side. So it become 3. So 3 equal to minus 2A. A equal to minus 3 by 2. We need to find out the value of B. We can use this equations. Okay, the equation number 5. Equation number 5 I am using. The value of C will be here. So 0 equal to minus 2B plus C, which is equal to minus 2B. C value is 1. Will come to left side. So 1 equal to 2B and B will be equal to 1 by 2. So our answer is A equal to minus 3 by 2 and B is equal to 1 by 2 and C is equal to 1. We have any equations will be there. A equal to minus 3 by 2 and B is equal to 1 by 2 and we have C will be equal to, the value C will be equal to 1. So we have 3 set of values which are given and which are matching with our A is equal to minus 3 by 2, B is equal to 1 by 2 and C is equal to 1, matching with the options number A. Okay, so this is the method I solved. It is not required you have to follow the same method. You can do it in any method, but finally aim is to find out the value of A. Okay, but in entrance examination I suggest you to do some method. This is one way of solving it. Another way of solving it in a very quick way is that you have A value, B value, C value given in your options, right? A value, B value, C value given in the options. You can substitute the A value will be here. You can substitute B value here. You can substitute C value from here. For example, from option number A. And you see whether if you are adding this all together, this is satisfying these equations, which means that what? If you are adding all the three values according to equation number 2, you should get 0. If you are not getting 0, that is not your right answer. That's another method of solving it. You can substitute here, you can substitute here, you can substitute here. Why I am saying you can substitute here means A will be there, B will be here, C will be there. If you are adding and if you are getting, answer will be equal to 0. First you substitute option number A. A, B, C values will be given. You can substitute here, check whether you are getting 0. If you are getting, just hold it. Do not mark it immediately. Go to the second option, option number B, substitute there. You check whether you are getting 0 or not. If you are not getting 0, 100% it's not the answer. Substitute C, substitute D. If you are not getting the answer with the C and D, then answer is A. Suppose, in case, if you are substituting in equation number 2, two option you are getting answer 0. Okay, two options you are getting answer 0, then there is a chance any one of them will be the answer. In that case, what you will do? You take the next equation, equation number 3. Here B, A and B will be there. Substitute A and B alone in this equation and check you are getting 0. Definitely, at least at this point of time itself, you can pick it one option satisfying both the equations. So go step by step, not in one shot. This is another way of answering, because option is already there, equation is already there. I can substitute in this equation and I can check which option is matching with my current equation. That is your answer. So without wasting the time, let's move to the next question, the third question of this session. Okay. Third question. Respective number of significant figures of the three numbers 23, 0.23, three numbers are given for you, and we need to find out the significant number of significant figures. What's the answer? First one is 23.023. How many significant figures are? 1, 2, 3, 4, 5. So 5 significant figures will be there. Second one, 0.0003. How many significant figures? All the leading zeros, or the zeros at the initial stages, are not significant. So only one significant figures will be here. Second one, 2.1 into 10 power minus 3. How many significant? All the powers are, all the power connected, 10 power x, 10 power 4, all these are non-significant. So this itself you can remove. So how many significant figures will be there? 2 and 1, 2.1. So we have two significant figures. So answer is 512. Your answer is option number A. 512 is the answer. Move to the next question. Question number 4. Young's modulus of the material has the same unit as that of. Young's modulus means what? Young's modulus. This you will learn on your at the middle of your first year topic, properties of matter. You don't want to by heart it, but just remember at the moment. Stress by strain. While I am taking the class itself, I told strain is a dimensionless quantity. Strain is a dimensionless quantity. There is no dimension for strain. Stress means nothing, force per area. So this has no dimension. So I am not writing that one for dimension. What is force per area? It is called pressure. So this is nothing but pressure. This is nothing but pressure. Already we have seen the dimension formula of pressure, right? Just before, two questions before. Question is asking Young's modulus of the material has the same unit as that of called pressure. Your answer is option A. Move to the next question. Question number 5. Which of the following quantities which one has dimensions different from the remaining one? Energy per unit volume. We have to see all the dimensions. We don't have no other way. Okay, in this case it is little bit time consuming, but yeah, we can solve this one. Energy per unit volume. This is the first option is given. Energy per unit volume. How to find out? Energy means what? Force into distance. Force in a dimension formula, mlt raised to minus 2 into distance means L. So ml square is energy. Volume means what? L cube. So what will come? M L power minus 1 T power minus 2 energy. Second options we'll see. Second option, force per unit area, F by A. Force in a dimension formula, mlt raised to minus 2, area L square. So formula is ml power minus 1 T power minus 2. This also has the same dimension. We'll move to C, third one. Product of voltage and charge per unit volume. Product of voltage into, this is voltage, and the charge per unit volume. Okay, here definitely at the second year you will learn one formula called QV. QV means energy. This is called volume. This is called voltage. That is given in the question, right? So do not confuse between two V's. That's what one I written capital, one I written small. QV, charge into voltage, is called energy. It's a unit of energy. So what? So the numerator, it is energy. Energy divided by denominator is volume. So this is similar to what? This is similar to the first one. So the first same dimension formula, ml power minus 1 T power minus 2. These both are same. So all the threes will be the same. So definitely the fourth one will be different, right? So they're asking which one is different from the remaining three. So angular momentum, definitely all these three are equal. So definitely fourth one will be the answer, but still we can solve. Angular momentum L equal to mvr. Let's see, mass is m, v is velocity, lt power minus 1, r is the distance which is called L. So what will get? Ml square T power minus 1. This is the dimension formula of this term is called angular momentum. Angular momentum. All these things you will learn it in your first year and second year. Once you are going rotational motion, one chapter will be there. Anyway, I am going to take that chapters for you definitely. So angular momentum is a term which we are going to learn it. Okay, so answer is here option D. This is the one which is different from all other three options what it is given there. We'll move to question number 6. Pressure on a square plate is measured by measuring the force on the plate and length of the sides of the plates. By using the formula P is equal to F by L square, if the maximum errors in the measurement of force and lengths are given respectively. Maximum error in the measurement of pressure. Question is given in terms of, you can see 1%, 2%, 3%, which means that what? It is something called percentage error. How will calculate the percentage error? We have the formula, pressure P is equal to F divided by L square. How will calculate the delta P divided by P into 100? This is called percentage error. This I want to find out. Delta F by F into L square. L square ne 2 times 2 times of delta L by L. Okay, whenever a power will come, that will comes as a multiplication. What is the percentage error in the force? 4%. So this is with 100, sorry, this is with 100. So the total value which is given will be here, and total value this one. This one is what? It is 4% plus length delta L by L into 100. Delta L by L into 100. This much factor. So 2 into 2%. So what will come? 8% is the right answer for this question. Quite simple, always asking. So percentage error means delta P by P, delta F by F into 100, 2 into delta L by L. If without 100, delta P divided by P is called relative error, right? Hope you remember. This is called relative error. When multiplying with 100, we'll get it percentage error. Next one, this 7th question. Siemens is the SI unit of. Now this is a new term for you, but if you learn physics maybe for next 10 months, this is a very common term for you. Siemens is a unit of, remember, it is called a conductance. Okay, conductance is normally represented by is represented by a letter called G, which is equal to 1 by resistance R. So resistance in a unit is called ohm. So ohm is a unit of resistance. 1 by ohm is also called mho. 1 by ohm inverse, which is also called reverse mho. This is also called Siemens. This is now, it's a new term for you, but definitely once you are learning the physics throughout there, definitely you will see come across this term is called this one. So Siemens is the unit of conductance. Conductivity, resistivity, okay, conductance and resistance we have seen now. Resistance is the blockage for the current actually. Okay, it is a resistance offered by a device. It's called resistor. Okay, and the conductivity I am not mentioning it now, that you will learn it in physics, because simply by hurting some formula will not work it at all. So we will see it on the run. We'll move to the next question. Question number 8. An object is moving through a liquid. The viscous damping force acting on it proportional to velocity. Viscous damping force, F is proportional to V. Definitely. For us, any force, damping or undamping, whatever, so damping force is proportional to velocity. Dimension formula of the constant of proportionality. So this constant is replaced with the kV. I want to find out the dimension of. So dimension of F is equal to dimension of K times of V. So we need to find out the dimension of K. So dimension of K is equal to, this is called proportionality constant. This is asked in the question. Dimension of F whole divided by dimension of V. What is the dimension of force? Mass into acceleration, mlt raised to minus 2. And V is called velocity, not volume, velocity, lt power minus 1. L get cancelled, t power minus 1 get cancels. What will come? mt raised to minus 1 will come. mt raised to minus 1. Which answer is matching with this one? mt raised to minus 1. Option number D is matching with that option. mt raised to minus 1. Option number D. Move to the next question. Question number 9th one. The least count of a stopwatch is 0.2 second. Time of 20 oscillations of a pendulum is measured to be 25 seconds. Percentage error in the measurement of this one. So percentage least count. When we learn about vernier caliber, when we learned about this meter bridge, not the meter bridge, I mean the screw gauge, I told the term called least count. Least count is a minimum difference. What is the minimum value I can measure? It is actually the difference between the two adjacent lines. In case of a scale, as I told, 0.1 centimeter is called the least count. So it is basically the time difference. Delta T will be equal to 0.2 second. For 20 oscillations, it is totally taking a time will be equal to 25 seconds. How to calculate the percentage error? So percentage error is equal to delta T divided by T into 100, which means 0.2 divided by 25 into 100. Okay, so this means how much will come? 20 divided by 25. This is 4 by 5, which is equal to 0.8 percentage. Answer is 0.8 percentage is the answer. 20 oscillation means while taking the 20 oscillation, 0.8 percentage of error will get introduced. That is the meaning. Okay. Question number 10. 10th question again. Weber is the unit of. This you will learn it in second year. At the moment, just understand, Weber is a unit of magnetic flux. In physics, in second year, you will learn one term is called flux. So this magnetic flux formula I am not writing at the moment. So magnetic flux in the unit is equal to Weber. So magnetic flux, the unit of magnetic flux is Weber. Okay. We'll move to the 11th question. The 11th question is specifying about the dimension formula. Mt raised to minus 3. Mt raised to minus 3 have a dimension formula for what one? The dimension formula Mt raised to minus 1, it's related something called solar constant. This is a new term for you, right? Write on the notebook. Solar constant will be equal to energy divided by area into time, AT, energy divided by AT. So we know the formula of energy. Energy means force into distance. Fs, force into distance, is called energy. So mlt raised to minus 2 force, distance means one more L, so it becomes L square. Area is L square and time is called T. L square cancels and it becomes mt power minus 3. This is the dimension formula of a term called solar constant. Okay, solar panels, solar things, you will learn it in physics also. That time you will come across the term called solar constant. Right now, remember, energy divided by area into time. We are substituting the respective dimension formula for energy, area and time, and we got finally the answer for solar constant. Okay, so this is matching with our option number B, solar constant. Surface tension, option A, already we know it is called force per length, and density also we know. Compressibility, it's not required for you. Next one, 12th one, the Wien's constant. This at the moment you can remember with a dimension formula, and the Wien's constant will have a dimension formula of Lk. Okay, Wien's constant. Twelfth one, Wien's constant will have a dimensions. Wien's constant will have a dimension formula of Lk. Remember like this one. Here L is a meter and length and K is a Kelvin temperature. Temperature the unit is called Kelvin, or the dimension formula is called K. So Wien's constant, you will learn it in another further physics, and Wien's constants will have a dimension formula of Lk. Remember this one.